Once we have defined the binary operation on a set, say the binary operation star on the set S, then we define the identity element, which is also in S, such that E operation X is the same as X operation E, and it's the same as X. In other words, it leaves every element that it is operated with unchanged, and this is always commutative. That is, it doesn't matter whether you put it where you put it in the order of the operation here. It can be before or after the element. If and when that happens, then the element E is said to be the identity element for the operation star on S. For example, some of the common known ones is that when we consider the addition of real numbers, then obviously the element that does not change any element is the element 0, because any real number A plus 0 is the same as 0 plus that real number, and it leaves the real number unchanged. In the same way, any real number multiplied by 1 is the same as 1 multiplied by that real number, and it leaves that real number unchanged. It is worth noting here that some operations do not necessarily have an identity element. For example, if we define subtraction in the set of real numbers, while x minus 0 is equals to x, 0 minus x is not equal to x. Remember, for that element to be an identity element, it has to be true that E operation X is equal to X operation E, and in this case obviously X minus 0 is not equal to 0 minus X, so there is no identity element if we define the operation subtraction of real numbers. A more practical example is example 41 from your notes. If I try to do example 41a, we define the operation A, operation B as 3ab, where this is the operation star on the set of real numbers. So if there exists an element E, which is a real number, then such that E is the identity element, then we will be suggesting that for all elements A in the set of real numbers, then A operation E must be equal to E operation A, and that must be equal to A. What does this mean in terms of this defined binary operation here? It would mean that A operation E, which is the same as E operation A, should be equal to 3AE. Now what we want to do is to determine, and this should be equal to A, we want to determine the value of E as defined by this binary operation. Obviously 3AE is the same as 3EA because multiplication of numbers is commutative. Therefore, what is left for us to determine is if 3AE is equals to A, then E must be equal to 1/3, and since 1/3 is a real number, that is, it is still in that set, then we say that the identity element of this binary operation as defined there is 1/3. It can be shown that this other example here does not have an identity element. Maybe that is what you need to try and figure out after watching this.